Okay, 4.6. We're going to do part of it today, and we'll work on finishing it up some more later. We're talking about the fundamental theorem of algebra. You guys have already been using this, okay? If I gave you a quadratic... Oh, my board's going to be off, so you're going to have to give me a second. I think I've recalibrated this every single class period today.
Oh, at least you know it works. Probably not.
All right. So I have x squared plus 3x minus 9. How many solutions should that have?
2.
Why?
Because it's a quadratic.
It's a quadratic. We know a quadratic has 2 solutions, right? How many solutions?
3.
How many solutions?
4.
So what are you looking at?
The degree.
The degree. You're looking at the degree, which is the same thing as the rest of you said, the exponent, right? You're looking at the degree of the polynomial. The degree of your polynomial will always match up with the number of solutions. So 4th degree, 4 solutions. 3rd degree, 3 solutions. 8th degree, 8 solutions. Now, that does not mean that they're all real solutions. Okay? If it was a real solution, that would be a 0 where it crosses the x-axis. Okay? So anytime you get a real solution, that is telling you that it is touching or crossing the x-axis at that point. Okay? Your imaginary solutions will not be on the x-axis because they're imaginary. They're not real. Okay? But they're still going to be there. So let's say I have a 4th degree polynomial. I have 2 solutions. I know that x equals 2 and positive 5. Okay? Those are my only 2 real solutions. How many imaginary solutions would I have to have?
2.
I would have to have 2. Maybe it's plus or minus the square root of 7. Well, it's got to be imaginary, so it's got to be plus or minus I square roots of 7. Okay? But I would have to have 2. Because no matter what, if it's a 4th degree polynomial, there is 4 solutions somewhere in that problem, whether they're real or imaginary. Okay? You have a chart there showing you the same thing we just talked about. The degree is going to match up with the number of solutions. Okay? So, if I give you this problem, f of x equals x to the 5th plus 3x to the 4th plus 9x cubed plus 23x squared minus 36. Okay, they give me that polynomial. They want us to find all of the solutions, or the zeros. Find all the zeros. Okay. First of all, how many are there?
5.
There are 5. Do we know at this time how many are real, how many are imaginary? No. Okay. Now a hint for you, imaginary, they're always going to be 2. Or, there's not always going to be 2. There's always going to be an even number. Okay, so it's either going to be 2, 4, 6, or 0, I guess. Okay, there will always be an even number of imaginary solutions. And we'll get into that more as we go into this lesson. Can I group this?
No.
Why?
Because there's 5.
There's 5 things. There's too much stuff going on, right? So what would you do first to try to start solving or factoring this?
See if you can take anything out.
Okay, first, is there anything I can take out of each one?
No.
No. Okay, so then what would you do? You'd have to use your synthetic division. Now remember, when we're doing our synthetic division, you're going to want to graph it first so you have a general idea of where those zeros might be at, correct? Okay, so let's say I want to draw this over here where
Just erase that.
I'm just going to move this down. Okay, so over here on the board I had this sketched. I don't know that, I didn't actually graph this problem. So I don't know that this is correct. But let's say this is x equals 1 and this is x equals negative 2. Okay, so here's, when I plugged it into GeoGebra, this isn't actually probably right. When I plugged it into GeoGebra, this is the graph I got. Okay, so what does this tell me? Where should I maybe start when using synthetic? I should start with either a negative 2 or a positive 1, right? Okay, now before we go into that further, what did it mean when the graph touched that point but came back down, never actually crossed over? There's 2 of these. Okay, so wherever this point is, if it's at negative 2, that means there's 2 negative 2's for my 0, excuse me. Okay, now, is it possible that this is maybe negative 2.1 or something like that?
Sure.
Possibly, but if you were to list out all your factors, negative 2 is going to be one of these factors. Okay, so I would go ahead and test that, or positive 1 first. So when I do this in synthetic division, I have a 1, a 3, a 9, a 23, a 0, and a negative 36. Got to be careful of that. Okay, they are missing the x to the first in that problem. So when I set up my synthetic division, on the outside we said we're going to test what first?
Negative 2.
Negative 2. Or 1, it doesn't really matter. So when I do this, you're going to have to do them all eventually. It's not going to matter. Okay, so I bring down my 1. Negative 2 times 1 is negative 2. 3 plus negative 2 is 1. Negative 2 times 1 is negative 2. 9 plus a negative 2 is negative 2 times 7. 23 minus 14. 9. Negative 2 times 9. 0 plus negative 18. Negative 18. Negative 2 times negative 18. 36. Negative 36 plus 36. 0. Okay, so it's not negative 2.1. It is negative 2, correct? So I got 0 for a remainder. Okay. So what does that mean?
There's no remainder.
What is one of my groups of parentheses? X plus 2. Since my factor, my 0 was negative 2, my factor is going to be x plus 2. And then that leaves me with a polynomial out of this, which would be x to the 4th plus x cubed plus 7x squared plus 9x minus 18. Okay. Can I group that set of parentheses on the right? Why? There's 5 things, too many things. Okay, so that means I need to do this again, correct? Now, I don't need to regraph this, because if it's a 0 at the beginning, it's still going to be a 0, right? Okay, so what's another 0 I could plug in? Okay, let's try 1. I do know that there should be another minus 2, right?
Yes.
Okay, but let's go ahead and do 1. So now I'm going to bring this down. I'm going to do synthetic division again. 1, 1, 7, 9, negative 18.
You started with 1.
You'd have ended up with something very similar, and you'd have had to do negative 2.
Okay.
Yep. Everybody hear that question? Zach asked, if you'd have started with 1, could you have basically got lucky and it would have came out easier? No. You'd end up with the same type of thing. Last class, we actually started with 1. You'd have had to do it again anyways. Okay, so I bring down my 1. 1 times 1 is 1. 1 plus 1 is 2. 1 times 2 is 7, and 2 is 1 times 9. 9 plus 9. 1 times 18. 0. Okay, so that 1, it wasn't a little bit off of 1. It was, 1 was definitely one of my zeros. So now, I have all this old, so I still have my x plus 2. But I also have an x minus 1 plus this, right? So now I have x squared plus, thank you, x cubed, plus 2x squared plus 9x plus 18. And I heard some of you saying it. Now I can do what? Now I can try to group. Now, does that mean that the grouping is going to work? No, but since I see 4 things, I am going to go ahead and try to group it because that would be easier than dividing again. Okay, so I'm going to group these and those. And what can I take out of here? Okay, so I take out my x squared and I'm left with x plus 2. Take out a 9. And I'm left with x plus 2. So grouping worked, didn't it? Because these are the same. So what are my 2 factors out of just my grouping then? X squared plus 9 from there and x plus 2. Do I still need to bring these 2 down? Okay, so I bring these 2 down. I have x plus 2, x minus 1. Okay, is this fully factored?
Yeah.
Yes. Is this fully factored? Yes. Is this fully factored?
No.
This is a plus sign. If it were a minus sign, it would not be, because there's a difference of 2 squares. But this is a plus sign. There's no such thing as sum of 2 squares. Okay, so this is fully factored. Is this fully factored? Yes. Okay, so we're done, but the problem asks to find all the real zeros. Or not all the real zeros, find all the zeros. So I need to do what with each group of parentheses? Set them equal to 0. So, this one would give me negative 2, 1, negative 2 again, which on your assignment, I think you just select which ones are zeros. So you're not going to be able to select negative 2 twice. So you might only have 4 boxes clicked, selected on a degree of 5 polynomial, but that's because one of them was twice. So just be aware of that. I did have that question last period. Okay, so I have 3 of them that took care of this one, and this one. It is not. So I need to take this, x squared plus 9, and set it equal to 0. And this is where people don't slow down enough and make that small mistake.
It's 9 over 2.
It's not.
What?
Solve for x. I move 9 over. So I have x squared equals negative 9. Square root. So x equals plus or minus the square root of negative 9. Square root of negative 9 is 3i. So I have x equals plus or minus 3i. So there's 2 more, right? So I have positive 3i and negative 3i. Okay. It was degree of 5. Do I have all 5 solutions? Yes. Okay. Again, if you have one imaginary solution, you should have 2. Always. If you have an imaginary solution, they're always going to come in pairs. Okay? And we'll look at that more as we go through this section. Okay, that's all the further I want to go today because I want you guys to practice that sum. I need you to finish through problem number 20 for tomorrow.